Hello learners, welcome to this course on embedded system design using PIC16F877 microcontroller. In this tutorial, I will be performing external event detection or counting using timer or counter modules in the microcontroller. So a timer or counter is a hardware available in the microcontroller. So this timer or counter can be used in a timer mode or in a counter mode. So in a timer mode, we can use it for measuring specific time intervals where the clock source is internal. For example, if I connect a 20 MHz crystal to the microcontroller, it is internally divided by 4, so it becomes 5 MHz. So the timer register incrementation happens at 5 MHz. Whereas in case of a counter mode, we are going to measure external events. So where the clock source is external. So clock source in the sense I am talking about the external event which is going to come from outside. So this external event will be used for incrementing your timer register content. So in this tutorial, I will be describing about how to use this timer module in a counting mode. So how to measure the external events or how to count the external events we will be describing in this tutorial. If you see the basic architecture of a timer module, so a timer module contains a register. If it is a 8-bit timer, it contains a 8-bit register. If it is a 16-bit timer, it contains a 16-bit register. So we try to load a value onto this timer register. And whenever an event happens, the incrementation of the value takes place in the timer register. So when a first event happens, then the value will change from 0 to 1. Second event, it goes to 1, 0. So like that it goes on. So subsequently we can compute 256 such events. On occurrence of the 256th event, the timer register overflows. This causes an interrupt to occur. So it can intimate the CPU that timer register has overflowed. So for counting, what we do is we put a value onto this timer register. Then whenever an external event occurs, the incrementation of that value is performed. By seeing the incremented value at what value it is right now, we can see how many times the event has occurred. So that is the logic behind on how to use this timer module for counting purpose. In case of a PIC16F877 microcontroller, we have 3 timer or counter modules. Timer 0, which is a 8-bit timer, which means it has a 8-bit register. Timer 1 is a 16-bit timer or counter. Timer 2 is a 8-bit timer. So here we have timer 0 and timer 1, which has both the modes, timer mode as well as the counter mode. Whereas timer 2, it supports only the timer mode. So let us take an example. Let me take timer 0 module. So here, as I said, this can be used as a both timing as well as counting operation. So here, if I use F oscillator by 4, which is internal clock frequency, then we call it as a timer mode. If I want to use this module for counting external events, then I should have a pin to connect that external event. So that pin is T0 CKI, timer 0 clock input. So this is the position where we connect the external event. So this external event can be used for incrementing your timer 0 register content. So we put a value onto this timer 0 register content. Usually it will be 8 zeros. Then whenever an event occurs on this T0 CKI pin, the incrementation of the timer 0 register content happens. We can also use a prescaler. So prescaler in the sense a register which contains a value. Depending upon this value, I can do the counting process. For example, if my prescaler value is 1:2, which means for every 2 events, an incrementation will happen. If my prescaler value is 1:1, then for every event occurrence, an incrementation will happen. If my prescaler value is 1:4, for every 4th event, an incrementation can happen. So this prescaler register can be configured. It is a 8-bit register. It can be set with any 8-bit value. Depending upon the 8-bit value, the prescaling of the event occurs. So 1:1 represents for every event the counting happens. 1:2 for every second event incrementation happens. For 1:8 for every 8th event an incrementation happens. So we can select at what count of an event our incrementation should happen, that we can decide as a programmer. So in order to do this, we need to know about certain registers like intercon register. Intercon is an interrupt control register. So here if you see, for timer 0 we have, if I want an interrupt to be generated, when the interrupt will be generated, whenever the timer 0 register overflows. So if I want to indicate it to the CPU, then I have to enable this timer 0 interrupt enable, and I need to enable the GAE. GAE is for global interrupt enable. So if I want to activate any interrupt, then this GAE should be 1, and this T0IE is for timer 0 alone, enable bit. T0IF is the interrupt flag associated with your timer 0. Whenever an interrupt is generated, this flag will be set. So CPU has to check this flag to identify whether the interrupt is from timer or from some other peripheral. If this bit is equal to 1, then the CPU will understand, okay, this interrupt is due to timer 0. Then it will try to execute the ISR related to that peripheral. Then we have another register called as option register. So in option register, I have certain bits like T0CS. So T0CS is timer 0 clock source. What type of clock I am going to use? Whether I am going to use an internal clock, which is nothing but the timer mode. If I use an external clock, that is a counter mode. So by setting it to 1, it will be as counter. Setting it to 0, it will be as timer. So this T0CS pin should be set to 1, since we are going to use it as a counter mode. Then I have T0SE. T0SE is timer 0 select edge. I have a pin T0CKI pin where the event occurs. So whether this event I need to recognize when it happens as low to high transition or high to low transition. So that can be programmed as well. So T0SC, if it is 1, then high to low transition on this T0CKI pin will be considered as an event. If T0SC is 0, then low to high transition on this T0CKI pin will be considered as an event. Then as I said, a prescaler is available. This prescaler register is common to both watchdog timer and a timer 0 module. So I have to specify whether I want to use a prescaler or not. If I don't use a prescaler, then it will work in 1:1 rate. If I use a prescaler, then I can do configuration. I can select different rates. So first thing is PSA. If it is 1, it is assigned to watchdog timer. If it is 0, it is assigned to timer 0 module. So if I set it to a timer 0, then I can change the rate by setting this PS2 to PS0, PS2, PS1, PS0. So we have, since 3 bits are there, 8 combinations are available. By setting a proper value, for example, if I put 0, 0, 0 for PS2 to PS0, then it is at 1:2 rate. 1:2 in the sense, for every second event, an incrementation of the timer register will happen. If it is 001, it is 1:4. If I put 111, it is 1:256. So 1:256 in the sense, for every 256th event occurrence on this T0CKI pin, an incrementation will happen. So this can be configured as well. So in this program, what we are going to do is, we are going to connect a switch to this T0 CKI pin. So this switch is used for creating an external event. So whenever I press a switch, it will go from low to high transition. Thereby the counting of that event will happen in the timer module in PIC16F877 microcontroller. Then that value, timer register content, will be sent to a 7-segment display using the IC7427 IC, which is a BCD to 7-segment drivers. So how many event has occurred, that we can visualize using this 7-segment display. As I said, 7-segment display, it contains 7 LED displays, which is named as A, B, C, D, E, F, G. So each module or each segment can be light up depending upon what type of digit we want to display. Mostly it is used for displaying numbers. So for example, if I want to display 0, then in that case all the segments except the G segment will be activated. If I want to put 1 on the 7-segment display, then B and C segments alone will light up. All the other segments will be in off state. So if I want 8, then all the 7 segments A to G will be activated. So depending upon what number we want, then the corresponding segments can be activated. So this 7 segment comes in both common anode mode as well as common cathode mode. In common anode mode, so from microcontroller I have to give logic common anode mode. From microcontroller I have to give logic 0 so that it will activate a segment. In case of a common cathode mode, a logic 1 from the microcontroller will activate your 7-segment display. So in this tutorial I am going to discuss about, we are going to connect an external event to T0 CKI pin, which is timer 0 clock input pin. The event occurrence is done by pressing a switch. Upon event occurrence, the timer 0 register content will be incremented, and that incremented value will be sent to 7-segment display, where we will see how many times the event has occurred. So depending upon the pre-scalar values, whether I am going to count for every event or I am going to count for every 2 events or 4 events or 8 events, it is going to be done by the program. Now let us go to the Proteus part and build the circuit. So this is a simple circuit which I have created in Proteus 8 environment. So here I have used a PIC16F877 microcontroller, and the oscillator pins are connected to 20 MHz crystal, and this 20 MHz crystal is connected with capacitors to produce a stable clock frequency. So and the memory clear pin is an active low signal, so I have connected it to a reset circuit. So by default this pin will be at logic 5. Whenever I close the switch, it will go to logic 0. So thereby reset operation will take place. So this is a clock circuit, this is a reset circuit. Then I connected an external event to pin RA4 T0 CKI pin, which is timer 0 clock input pin. So I have connected an external event. So external event is done by your pressing your switch. So by default this pin will be at logic 0, since it is connected with the help of a resistor and a ground, it will be at logic 0. Whenever I close the switch, this pin will go to logic 5. So I try to see a low to high transition on this pin. We try to visualize a low to high transition on this pin. Upon occurrence of the low to high transition, the timer 0 register content will be incremented, and that incremented value is going to be sent through this RB0 to RB3 pin, and this value gets converted into 7-segment values using this IC74247 IC, which is a BCD to 7-segment converter. So the BCD inputs are A, B, C, D, 7-segment outputs are QA to QG. and it also has some control lines like blank input, lamp test. So these things we are not going to use. So we have connected all these things are active low signals. So we are going to connect it to a supply. So thereby we are deactivating these signals. And the 7-segment output is connected to a 7-segment display. So here I have used a common anode type, which means all the anodes of the segments are connected to a supply. So a logic 0 from this QA to QG will activate a segment. So this is the circuit construction part for our counting external events. Now let us go and discuss the programming part. So the programming is done using Micro C Pro for PIC compiler. So here you see I have set the microcontroller which we use is PIC16F877 microcontroller, and the oscillator frequency I have set it to 20 MHz. So we start with the main program. First thing is, since we have connected a 7-segment display to port B, I have to set it to output port. So for setting it to output port, I use a data direction register which is TRISC-B. By setting it to 0, we are going to configure it as an output port. If I set it to 1, we will be configuring it as an input port. Since we have connected a 7-segment display, it is an output device, so I have set it to 0x00, which means 8 zeros. 0x stands for, it represents the number is a hexadecimal number. So I have configured port B as an output port. Same way I have connected a switch to port A 4th pin, T0 CKI pin. So in order to configure this T0 CKI pin as an input, I set this TRISC-A 4th bit F4. TRISC-A.F4 is set to 1. So thereby the port A 4th pin will act like a input pin. Then I am going to initialize the timer 0 register with 0x00. Then I am going to do the configuration part. Option register, I am going to set it with 0xA0. So A0 means A0 means I am going to put 1 0 1 0. So this is A, and here I am going to put 0. So which is 0 0 0 0. So option register I am setting it with A0. So what it represents, RBPU, I am deactivating it. So RBPU is nothing but port B pull up. So we are not going to use port B pull up, so I am deactivating it by putting it to 1. Then INTH is for external interrupt. So we are not going to use it, so I am going to make it as 0. T0CS. So T0CS I am going to set it to 1. So set it to 1 in the sense T0CS, if it is set it to 1, then we are going to use it as a counter mode. Then T0SC I am going to set it to 0, which means I am going to use a low to high transition on the T0 CKI pin as an event. Then PSA is set with 0, which means prescaler is assigned to timer 0 module, and I have set with PS2 to PS0 as 0 0 0. So 0 0 0 means it is 1:2 rate, which means for every second event, incrementation of the timer 0 register will happen. So if I want to do it for every event, instead of every 2 events, if I want to do it for every event, then what should be the value? In that case, if I want to do it for every event, then what I need to do is, I need to put a value. I don't want a pull up, so I will put it as 1. We are not going to use external interrupt, so I am going to put it as 0. So this I need to configure as a counter mode, so I set it to 1. Again I take low to high transition, so I am going to set it to 0. So now instead of using a prescaler, if I use a prescaler, then it will be between 1:2 to 1:256. If I don't use a prescaler, in that case I can get 1:1 rate. So if I don't want to use a prescaler, then I can configure it with 1. So if I put 1, then the prescaler will be assigned to watchdog timer. It is not assigned to timer 0. So I don't worry about this PS2 to PS0. So I can put it as 0, 0, 0. So in that case, what happens? So this is A8. Right? So if I put A0 for option register, then I try to count every second event. Every second event will be counted. If I put A8, then every event will be counted. Every event will be counted. So that is the difference between A0 and A8 here. So we can change this and we can see how it works in our program. So as I do here I have put A0, which means for every second event I am going to count it. After running this, I will just change this value to A8 and I will show you for every event how it gets counted. Then intcon register, I am going to disable it by putting 0x00. So here if you see, I am going to put 0. So 0, 0, 0, 0, 0, 0, 0, 0, which means since I am putting 0 to the global interrupt enable, all the interrupts will be disabled. So I am not going to use interrupt concept here. So I am going to set it to 0x00. Then I initialize the port B with 0x00. Then in a while loop, what I am going to do, I am going to take the timer 0 register content, put it to port B. And since I am using only one 7 segment display, digits from 0 to 9 alone can be displayed here. So what I am doing is, in a if, I am going to check whether my timer 0 content has reached greater than 9. If it is so, I am going to reset it to 0 again. So this is a very simple program where when an event happens, the timer 0 register content will get incremented and that value is sent to the 7 segment display. So once after completing the program, let us build the program. So now the program has been built. Now let us go to the Proteus environment. Now I have to load the text file into the microcontroller. Right click on the microcontroller, edit properties, select the program file. So here the program file is LED underscore timer 0 underscore counter 7 segment.x. Okay, so I am loading it. Set the clock frequency to be 20 megahertz. Press OK. So now the X file is loaded onto the microcontroller. Now let us see how it works. By pressing this play button, you can see right now it shows 0. So now it is configured for every 2 events incrementation will happen. So first let us create the first event. So I am going to close the switch, release the switch. So one event has happened. So there is no incrementation occurs. When I do it for the second time, you can see it gets displayed here. Same way when the third time nothing happens, and on the fourth time you can see there is a value gets incremented. So since we have used a prescaler value of 1:2, this happens. For every 2 events, an incrementation of timer 0 register content happens. So now let us just change the program to count every event. Now let us go to the program. So instead of option register A0, as I said, I will put it as A8, which means the prescaler is assigned to watchdog timer. It is not assigned to your timer 0, which means I am going to use 1:1 rate. So after doing this, I just build the program to create a new X file. Go to the simulator, load the text file to the microcontroller, set the clock frequency. Now let us play. So again 0. Now you can see for every event occurrence the incrementation will happen. So when I close the switch, you can see it got incremented. So I release the switch. Again when I create another event, you can see it gets incremented. So for every event an incrementation is happening. So this is how an external event can be counted using a microcontroller. So in this tutorial, I have talked about on how to count the external events using timer or counter module in PIC16F877 microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.